When Charles Goodyear discovered vulcanized rubber in 1839 by total accident, it changed the tire game forever. His invention started a snowball effect that resulted in the invention of air-filled tires. In the early part of the 20th century, factories produce more than 250 million new tires a year. Before a tire is actually approved for mass production, engineers craft the design in specialized computer software. This software allows tire engineers to simulate the performance of tread, design, and other design parameters. Software creates a three-dimensional color image of a possible tire design and calculates the effects of different stresses on the proposed tire design. Computer simulations save money for tire manufacturers because many design limitations can be discovered before a prototype tire is actually assembled and tested. After the design is approved, manufacture can finally begin. The modern tire is made up of 10 to 15 different components, which include natural and synthetic rubbers, chemical additives, and carbon black, a pigment. These materials are delivered to the factories in rail cars and are transferred to storage. Then computer systems measure out specific batches of rubber and chemicals for mixing, which are then sent into a Banbury mixer. The Banbury mixer consists of a large, cylindrical mixing chamber with two intermeshing rotors inside. Before the mixing process begins, the mixing chamber is heated to raise the temperature of the rubber compound. Heating softens the rubber, making it more malleable and easier to blend with the other ingredients. Once the chamber is heated, the rotors start rotating in opposite directions. As the rotors move, they create a shearing and kneading action within the mixing chamber. This action causes the rubber and other ingredients to blend together. There are different formulations for different parts of the tire, however. In each case, the result is gummy rubber dough, which machinery rolls into sheets to await further kneading and processing. For the corded ply, polyester unrolls into a machine called a calender. The calender is equipped with rollers that apply warm rubber to both sides of the fabric. This produces a rubberized fabric that will be used to reinforce the tire. This fabric ply is needed because rubber alone isn't sturdy enough to make a tire. Numerous cotton cords spinning off of bobbins are now pulled into the rubberized fabric. This cording provides channels, preventing air during the tire building. The tread is the outermost part of the tire that comes into contact with the road. It is made of a specially formulated rubber compound with unique patterns and designs for optimal traction, handling, and wear characteristics. Making rubber for tread requires 3 different rubber formulations. Extruders shape the 3 streams of rubber, and then they enter a die that forms them into one. Many paint rollers apply different colored stripes. This way, the factory can identify the different ingredients during processing to avoid tension. The system creates slack in the feed blade, then slices the tread rubber to length. Finally, it's time for all the elements of the tire to come together. The tire building process usually begins with a worker placing the bead rings on a special rotating drum. Next up is the inner liner. The inner liner is a thin layer of rubber that provides an airtight seal, preventing air from escaping through the tire. It also serves as a barrier against moisture and helps maintain proper inflation. The inner liner is then covered with the corded ply. The corded ply provides strength and stability to the tire, reinforcing it against internal pressure. The next step involves adding beads to the tire. Inflated bladders roll the rubber around the bead on both sides and then retract. The sidewalls are then added to the beads. Little rollers then fold these sidewalls over the beads. Sidewalls are made of rubber and provide protection and flexibility to the tire. They also contain various information, such as the tire size, brand markings, and other sidewall specifications. This completes the inner skeleton of the tire. The outer shell is manufactured separately and typically begins with the wrapping of belts around another drum. Belts are typically made of steel or other reinforcing materials embedded in rubber. These belts help enhance the tire's strength, improve resistance against punctures, and provide stability during high-speed operation. The number and angle of the belts can vary depending on the tire design and performance requirements. The belts are then covered with narrow strips of rubber ply. A computerized system lines them with just the right amount of tension for a graduated effect. Finally, the tread is applied to the ply. The two tire fabrications are now ready to become one. A transfer ring collects the outer assembly and transfers it to the inner part. Compressed air then inflates the tire to shape it, and all the sticky layers adhere together. A machine rolls the edge of the tread rubber over the sidewalls. They now have what is known in the industry as a green tire, an uncured tire without tread pattern. It's surprising to know that until 1909, a tire assembly was done by hand. It wasn't until Goodyear patented their revolutionary tire building machine that the process was automated. This core building machine simplified and sped up production from 6 to 8 tires per day, per worker to 20 to 40 a day, depending upon the type. The green tire is placed inside a large mold. For the curing process, a tire mold is shaped like a monstrous metal clam, which opens to reveal a large, flexible balloon called a bladder. This green tire is placed over the bladder, and as the clamshell mold closes, the bladder fills with steam and expands to shape the tire and force the blank tread rubber against the raised interior of the mold. During this curing process, the steam heats the green tire up to 280 degrees. Aside from the molding, the time in the hot, pressurized mold causes the rubber to vulcanize, a chemical reaction that transforms it from a weak, sticky substance to one that's strong and elastic. After curing, excess rubber is trimmed away, leaving a clean and smooth tread surface. The tire then undergoes a thorough inspection to detect any defects or abnormalities. This step is crucial to ensure quality, control, and safety. When a new tire design is being manufactured for the first time, hundreds of tires are taken from the end of the assembly line. For destructive testing, some of the tires, for example, are sliced open to check for air pockets between body plies, while others are pressed down on metal studs to determine puncture resistance. Still other tires are spun rapidly and forced down on metal drums to test mileage and other performance characteristics. Once the tires pass inspection and testing, they undergo additional finishing processes. These include applying a layer of protective coating, marking the sidewalls with brand names and tire specifications, and adding any required labeling or branding elements. The finished tires are packaged and prepared for distribution. They are typically stored in warehouses before being shipped to retailers or automotive manufacturers. The global tire market attained a volume of $314.07 billion in 2022. Driven by growing demand from the developing regions and rising technological advancements, this number will continue to grow bigger as the population continues to explode. If you like this video and want to watch others like it, head on over to this one.